Welcome. Today we explain Apache Hive, what it is, why it matters, and how it works.
Apache Hive, a data warehouse layer built on top of Hadoop. It lets you query and analyze very large data sets stored in HDFS using HiveQL, a SQL-like language.
Hive was developed at Facebook so analysts could query big data without writing Java MapReduce.
Behind the scenes, Hive converts your queries into MapReduce, Tez, or Spark jobs and runs them on Hadoop.
For example, to count words you simply write select word count from words_table group by word.
Without Hive, you would write complex Java MapReduce programs. With Hive, that single SQL-like query does the job.
Much simpler, right?
Next, why teams use Hive and its advantages.
Let's look at the key advantages. Hive bridges the gap between SQL knowledge and big data, making analytics accessible.
Key advantages.
1. Ease of use. Anyone who knows SQL can use Hive without writing MapReduce or Java.
2. Scalable. Hive processes terabytes or petabytes by distributing work across a Hadoop cluster.
3. Schema on read. Data can be stored without a strict schema. Schema is applied when you query.
4. Integration. Hive uses HDFS for storage and Yarn for resource management.
5. Works with text, CSV, JSON, Avro, ORC, Parquet. Columnar formats like ORC and Parquet speed queries and compress data.
6. Best for batch processing and analytics, not for OLTP or real-time transactions.
Example. A retail company stores 10 terabytes of daily sales data in HDFS.
Analysts write, select region sum sales from sales_data group by region. That runs as a distributed job and returns insights in minutes.
Hive translates your query into a distributed execution plan. Parallel workers make it fast at scale.
The result is actionable analytics for business teams.
Hive exposes JDBC ODBC endpoints so BI tools like Tableau and Power BI can query data directly. So Hive brings familiar SQL to big data ecosystems, saving time and reducing complexity.
Now let's dive into Hive's architecture and how a query flows.
We will cover the UI, driver, compiler, Metastore, execution engine, and HDFS step by step.
Hive query flow: UI, driver, compiler, Metastore, execution engine, HDFS.
Let's break down each component.
User interface: queries enter via CLI, Web UI, or JDBC ODBC used by BI tools.
For example, select from employees limit 10 in the CLI.
Driver manages the query lifecycle: sessions, syntax checking, and forwards queries for compilation.
If a column name is wrong, the driver rejects the query before execution.
Compiler converts HiveQL into an execution plan and consults the Metastore for table metadata.
A group by becomes map, shuffle, reduce jobs.
Metastore is the central repository storing table schemas, partitions, and HDFs locations, typically backed by MySQL or Darby.
When a query needs the employees table, Metastore returns columns, types, and the file location.
Execution engine orchestrates execution by communicating with Hadoop. It runs the plan via MapReduce, Tez, or Spark.
The logical plan becomes parallel physical tasks across the cluster.
HDFS stores the actual data. Hive provides the query layer on top of that storage.
Remember, Hive queries data stored in HDFS. It does not replace storage.
Recap: 1. User submits query. 2. Driver checks syntax. 3. Compiler makes the plan. 4. Metastore supplies metadata. 5. Execution engine runs the plan. 6. Results return to the user.
In short, Hive gives you a SQL-like interface for big data, removing MapReduce complexity while scaling to large datasets. In the next video, we'll explore Hive tables, partitions, and bucketing with hands-on examples. Don't forget to like and subscribe.